Welcome to the Medical Minimus Podcast, your source for memory techniques and accelerated learning in higher education. Now, here's your host, Chase DeMarco.
Cam Knight is joining us today to discuss some of his personalized theories on accelerated learning techniques. He is the author of several best-selling books on learning, memory, and productivity. He is about to release an online course of which details can be found at his website, mindlily.com. So, Cam, how are you doing today?
I'm doing great. Thanks for having me on the show, Chase.
Great. I think we're going to have a fun episode based on how many hiccups we've had so far. But
yeah,
let's talk a little bit about you and your educational background and course and all these great resources that you have.
Okay, great. So my name is Cam Knight, and I'm a coach, writer, and author of several best-selling books in the area of mental performance, such as memory, concentration, and productivity. And over the last 15 years, I've more or less dedicating my life to understanding the mind and how to optimize it and make it perform better. And so I'm not one to tell people what to do or how to do it or what they shouldn't do or how they shouldn't do it. I focus more on the middle ground of how to get people to do what it is that they want to do. And by middle ground, I kind of talk about these specific things that really help us accelerate our lives, being more focused, being more productive. And in this case, memory. Memory is really key to our productivity and our ability to do more and have more in our life.
Yeah, definitely. Students really like to learn what is going to help their memory and also productivity. You're so busy, anything to cut a little time out of your day and add to either study time or personal time is always great information to have.
Yeah. And so I'll just kind of start off by saying one of the most important fundamental things that I teach, especially when I'm coaching, is that diamonds are forever, but memories aren't. So just because we come across a piece of information, no matter how important or valuable it is, doesn't mean that we're going to remember it. It's really important for your audience and people to realize that our mind is built to make us forget. And it's hard to imagine that, like, why would my mind make me forget? But it's true. Our mind is designed to make us forget. And there's all sorts of complex reasons why that is. For example, most of us come across way too much information on a day-to-day basis. And majority of that information is useful, not for the long term, but just for the short term. And keeping all that information in long-term storage would not be beneficial because the brain would have to sift through a lot of information to get to the information you wanted. So what the brain does is it discards what it thinks is not going to be useful so it can operate more efficiently. But the problem is what the mind thinks it's going to be useful is different from what we may find useful. You know, we may think like a great advice or content that we're learning in school might be important, but that's not the criteria the mind uses. The criteria the mind uses is something different. So as long as information is presented within the mechanical limits of the brain, then the brain will retain it. But if it doesn't, then the brain won't retain it, no matter how important, valuable, and painfully obvious it is.
Darn evolution. If only it would go the way we want it to. Makes sense that you can remember some things better for, evolutionary sake, but our world is so different now and our education system is so complex that learning some of these techniques that get us past our natural abilities or natural evolution is probably very useful.
Yeah.
So what are some of the topics that we're going to cover today?
So I would like to first talk about repetition. I know, and I'm sure that many of your other guests have talked about repetition before, but I want to quickly just talk about repetition and talk about how and why it's so important. And then we can go into a technique called visualization. And then later on, we can discuss a little bit of mind mapping, if that works for you.
Yeah, sounds great.
Okay.
All right, let's get to it.
All right, great. So I want everyone to understand, including your audience, how important repetition is. It's a fundamental of all learning because every time a memory is formed, grooves or tracks are created in the brain. You can think of these grooves or tracks like footprints or breadcrumbs that lead to that specific memory. The more you repeat a certain information, the deeper those grooves or tracks get, making it easier for the brain to locate that memory. Now, what's really important to understand is that those grooves and tracks, they don't deepen by how important and valuable that information is, which goes back to what I said earlier. We can't expect to remember information just because it's important and it's very necessary. Those grooves and tracks are deepened only through repetition. The more we repeat a certain type of information, the deeper those grooves and tracks get, and the easier it is for us to remember that piece of information.
Perfect. So it's kind of the statement, neurons that fire together, wire together. So these grooves not only are independent of one another, but they can become Grand Canyons in your memory. That's a terrible analogy, but we'll leave it in anyway.
No. I think it's a good analogy. It's like Grand Canyons. The deeper those groups get, the more solidified that memory is going to be, and the longer it's going to stay there, just like the Grand Canyon, which has been around for hundreds of millions of years, I believe.
Probably something like that. Yeah. All right. So we kind of have some techniques here as far as repetition and sort of how that affects your memory, how it improves in your memory and makes it a deeper, longer lasting memory, which you definitely need because the material you learn when you first start off in medical school, for instance, you might not be tested on for 3, 4, 5 years, if even longer. So remembering that for long term, very useful. What are some of the other techniques that we can use here, or how do we implement repetition in a productive manner?
Okay, so when people think of repetition, they usually think of the rote variety, verbally repeating or echoing something over and over. And although this is one form of repetition, it's not the only form. Repetition can come in a variety of forms. You can take notes on information. That's a form of repetition. If you preview material before you start reading it or going to a lecture and learning about it, that's in a form of repetition. But it gets more involved than that. Retrieval, I know it's a technique that's been discussed by one of your guests before, is also a form of repetition. Visualization is a form of repetition. And if the information requires us to do something, then acting on that information is repetition. And more importantly, teaching others is a form of repetition. So in a way, repetition is exposing your mind or brain to the information as much as possible. So I don't really like to use the word repetition too much because people have bad associations and connotations. But if people can think of it in terms of the more you expose yourself or the more you expose your mind to a particular information, the more it's going to retain and remember it.
Yeah, and spaced repetition is definitely something, a retrieval practice that we discuss in, I think, several episodes at this point because it's so packed full of useful techniques and is very much evidence-based. So repetition in different manners, though, can be a lot more interesting. Most often, students think of it in the form of maybe flashcards, note cards, reading your notes, something like that. But like you said, visualizations or an action or something other that's more active is going to most likely deepen the memory for each repetition.
Yeah. And another aspect of one of the reasons repetition is so useful is because, memories aren't stored in a specific area or region of the brain. Memories are actually stored all over the brain, and not just the brain, but throughout our entire bodies. So when we're using the different forms of repetition, like visualization or retrieval or taking action or teaching, it's actually activating different parts of the brain and recording the information in different areas. So we have the information recorded multiple times, and it makes it much easier to not only retain it, but to recall it when we need it.
Great. So with the repetition, are there any other particular techniques that you would recommend, or should we discuss some of the other memory techniques that you discuss in your books and course?
Yeah, so we can jump right into the visualization because visualization is what I found to be extremely effective with all types of information. So visualization more or less is just creating mental images. It's using your imagination to sketch a picture, scene, or process in your mind of information you want to remember. So Chase, you know what a dolphin looks like, right?
I sure hope so, yes.
Yeah, and you know the color red. Now, if you were to imagine a red dolphin, you'd be using visualization. So humans, our dominant sense is sight. For dogs, it's smell. And for bats, it's sound. But for us humans, we remember pictures, places, and faces much better than any other type of information. In fact, 50% of the brain's processing power is dedicated to processing visual information. And we remember as much as 50% of what we see as opposed to what we hear or read, which only has a memory accuracy of about 20%. So as you can see, our mind is built to process and retain information that is seen. And I can illustrate with an example. When you think back to your childhood of all the places that you've been to and grown up in, you can remember the details of the places extremely well. For example, your home, you remember exactly where the living room and dining room are located, as well as the kitchen and other rooms. But what we have difficulty remembering is the name of those places or the phone numbers. The same thing with our neighborhood. We can probably get a crystal clear image of our neighborhood come up in our minds, no matter how long ago that was. But the names of those streets and the intersections are what's not going to come up. And the same applies to people. We remember people's faces, but not so much people's name. You never hear somebody going, "Oh, I remember your name, but I don't recognize your face." all of these examples illustrate how powerful our sense of sight is. And that's what makes visualization so great, is because it helps you visually see the information.
Makes sense why the statement "a picture's worth 1,000 words" is so predominant. And I definitely agree. I've lived in so many places at this point. I could still visualize the exterior, the interior of most of them. But if I didn't have a running list of addresses, there's no way I would know where any of those places were anymore.
Yeah, exactly. That's how it is with me as well. Like, I could remember the phone number of the first place I lived in, like the first house I grew up in. But since then, I don't remember the phone numbers of any of those places. But I can recall the actual place itself in exquisite detail. Now, when it comes to visualization, I'll just kind of give you a very simple example of how it could be used to remember information. For example, if I got a new ATM pin, let's say 2465, I can use visualization in one of few ways. I could just visually see the numbers of the ATM pin, 2, 4, 6, and 5. Or I could visualize myself writing that number down, 2, 4, 6, 5. Or another way is to visualize myself at the ATM keying in those numbers. So with my middle finger, I'd hit the 2. With my index finger, I'd hit the 4. With my third finger, it'd be the 6. And then with the middle finger again, the 5. Or another way is just to visualize the keypad and see the numbers that I wanted to remember light up in the order and sequence that I wanted it remembered. So I'd see the 2 light up first, and then the 4 light up next, and then the 6 light up, and then finally the 5. So this is just a really quick example of what visualization is in terms of memorizing information, but it can be used to remember much more and in much more detail as well.
I always use something similar in, especially anatomy. So I do it in 2 different ways, sort of like a 3D anatomy software where I can kind of visualize the different layers from the organs to the bone to the nerves, the skin or muscles. But also if you're trying to picture something inside or something that's more 3-dimensional, such as the whole GI system or anything in your abdomen and thorax, it can be a little complex to get like a 2D image. So if you can picture the old cartoon, The Magic School Bus, when they shrink down and go inside bodies and stuff like that, well, then you have a really interesting visual of like the whole human body. And it's a better way to try to remember where everything is in association with itself.
Yeah, exactly. That's like the perfect analogy, especially for med students, for using visualization, is thinking of that old cartoon, The Magic School Bus, where all the kids would jump on this bus and then the bus would shrink or get bigger depending on where they were going. And if they were going inside an animal or a human body, it would kind of take you on a visual journey of what was going on in each step. So actually, I have created a few visualization scripts for your audience that I would like to have them go through so they can kind of see what it's like to visualize and how it could be very helpful. So you think that would be something you want to do that?
Yes, and fair warning, anyone that's driving, if you are doing anything that requires your eyes to be open, now might not be the best time to put this into practice.
Yeah, exactly. So if you're driving, make sure that you don't close your eyes and wait until you get home to close your eyes. But if you're not driving, let's get on with exercise. So one of the things I want to do is cell mitosis. So as most know, it's part of the cell cycle where the cell splits and forms into 2 new cells. Mitosis has many phases. The beginning phase is interphase, where the DNA is copied and condenses into chromosome pairs. Also, the nucleus disassembles and the chromosomes line up in the middle of the cell. So I'm going to walk you guys through this process. So everybody listening to this, close your eyes. And if you're driving, keep them open and visualize the process as I narrate. So now that everyone's eyes are closed, first, we're at the interphase. Imagine a cell with the nucleus in the center. Inside the nucleus are strands of DNA. Watch these strands of DNA duplicate. Now we enter prophase. Notice the DNA condense into chromosomes. The next phase is prometaphase, where the nucleus begins to dissolve and the centrosomes move to opposite ends of the cell, and their tentacle-like spindle fibers reach out and attach to the chromosome. So first, visualize the nucleus actually disappear. Then visualize the 2 centrosomes move to the opposite ends of the cell and attach to the chromosomes with their spindle fibers. Now we enter metaphase, where the chromosomes line up in the middle of the cell. The chromosomes line up in the center as one line. So picture that happening, all the chromosomes next to each other in a straight line. In the next phase, the anaphase, the chromosome pairs break apart and each is pulled to separate ends of the cell by the centrosome's spindle fibers. So see the spindle fibers pulling the chromosomes to their end of the cell. Now we're in the final phase, the telophase. The spindles detach from the cell and new nuclei form around the chromosomes. So here we visualize two nuclei forming around the chromosomes on each end of the cell. And then finally, watch the cell divide into two distinct cells with two identical nuclei. So this is a simple example using information that med students would be learning. But as you go through the image, you can add more and more detail. For example, the centrosome spindle fibers attached to a protein in the center of the chromosome called kinetochore. So you can put that detail into your visual. And as a student, the more classes they take and the more they learn about a specific body part or function, they can add more of those details to their images that they visualize regularly. They would have a really strong recollection of that information.
I want to announce the holiday sale. Within the next few days, we will be greatly reducing the price on both the Kindle version and the paperback version of Read This Before Medical School. So if you haven't gotten your hands on a copy yet, or if you know someone that might want one, it'll make a great holiday gift. Go on Amazon, check the show notes here or freemeded.org/medstudent for more details. Now on with today's show. That's a great point and a great example there. I actually had an idea several months ago that I was trying to implement to make sort of guided meditations and visualizations for medical students. And it would basically be just like this process. So I'm glad that you are able to give that example to students and they can make their own. I've heard of some even creating their own. They record it once and then they listen to it with their eyes closed later on. So it's kind of creating your own guided meditation. So really unique ways to implement these tactics into your normal study routine.
Yeah, wow, Chase. I actually had never heard of that, like guided meditations with med student topics.
Yeah, it's not something that's out there right now. And I tried to get some of my buddies at Inside the Boards to work on that with me, but everyone's so busy with so many projects right now. We haven't been able to get that off the ground yet. Maybe by the time this airs, it'll be out.
Wow. Well, if you need somebody to work with you on that, I wouldn't mind doing that. It sounds like such a cool way to get med students to be much more into the information that they're learning. It's a great way for students to be able to learn the information if they can actually visualize it, which is what I'm teaching. But if there was tapes that actually guided them through the whole process like this, I could see being really effective and powerful.
Exactly. I completely agree. Always looking for new, unique ways to learn this material and teach it.
Yeah. So I just want to kind of point out a couple of things before I have them go through another example, is that when doing this visual exercise, you can actually add anything you want to the images. You can have like arrows pointing to specific parts of the images to really hone in on a specific definition or specific term. For example, like the chromosomes connected to what's called the kinetochore. So what somebody could do is they can visualize the cell and then they can visualize the nucleus of the cell. And within the nucleus, they can see the chromosomes and then an arrow pointing to the center of the chromosome with the label kinetochore. So this is a really good way to enhance the visualization. And another way to enhance it is by adding visual cues that we would in traditional memory palaces. So when I think of centrosome, I think of people who do rappelling. You know that sport where people scale down the side of mountains?
Yeah, not going to catch me doing that.
Yeah, well, you can visualize yourself doing that. Like from the centrosome, you can rappel down to the chromosome before the chromosomes detach from each other. Or chromosomes actually kind of pair up with sister chromatins. So each side of the chromosome, you can picture twin sisters named chromatin. So adding these personal touches can really help to make the visualization and the images that you're visualizing more memorable.
That's great. So we're mixing a couple of techniques with the visualizations. So kind of like a cartoon or a YouTube video or something to really get a visual representation of the material we're trying to learn, but then also adding your own personal touch, your arrows and notes, and using traditional mind map and memory palace techniques to add little funny visuals to make it more memorable for you. I like it.
Yeah. And what's great is like the more you go through the sequence, the more you're going to remember. And the more you learn, the more you can add to the sequence. There's any specific areas that are confusing, you can hone in on them with the arrows and with personal touches. So it's a really good exercise to be able to retain lots of data in detail. So as I mentioned, Chase, that was one example. I kind of want to go through another example just so your audience can kind of see different ways of how visualization can be applied. And I know you kind of talked about digestion and the GI tract. So I'll use that as an example. So we know digestion starts at the mouth and moves through the esophagus, stomach, and through the small and large intestines, and finally through the rectum. So I will take everyone through a sequence visualizing that. So everyone, let's close our eyes again, and we'll start at the mouth. First, visualize the teeth, chew, and break up the food. During chewing, food mixes with saliva, which is released by salivary glands located between the lower jaw, tongue, and teeth. So picture exactly where the salivary glands are located and see them releasing the saliva, which mixes with the food. The tongue plays an important role in digestion as well. The tongue has taste buds, and different regions of the tongue detect different tastes. So visualize those regions clearly. The food then travels into the esophagus. It is directed into the esophagus by a flap-like structure called the epiglottis. So see the flap direct the food into the esophagus after it is swallowed. The esophagus is a muscle, so it expands and contracts to push the food down its tract. So picture the expanding and contracting of the esophagus driving the food down. The food then enters the stomach. The stomach is a bag-like structure with thick walls. So see an exact picture of the stomach. The food that enters the stomach mixes with mucus, hydrochloric acid, and digestive juices. So picture the mucus, HCl, and digestive juices releasing onto the food. And here you can even notice the different colors of the liquids, actually breaking down the proteins into simpler substances. Then the food is emptied into the small intestine. The small intestine is a coil-like structure, so see it wound and twisted up. As soon as food enters the small intestine, digestive juices from the liver and pancreas are mixed into it. The liver releases bile, and pancreas releases pancreatic juice. See both the bile and pancreatic juices release into the food. In the small intestine, carbohydrates break down into glucose, fats into fatty acid, and proteins into amino acid. So picture all of that happening. Now the food is ready to be absorbed by the body. The small intestine also has a large network of finger-like projections called villi, which have thin blood vessels that absorb the food. So picture the glucose, fatty acid, and proteins absorbed by the villi and enter into the bloodstream. What is not digested enters the large intestine. The large intestine absorbs water and salt, and what is left passes through the rectum. So this is like another example of how we can visualize a complex process or different parts with a lot of details that we need to remember and keep straight in our head.
And for the GI system, being that it is such a complex system and there are so many chemicals, there's CCKs, secretin, amylase, lipase, knowing where water is more absorbed, what part of the intestines absorbs more iron than the other. These are all questions that can be, or these are all topics anyway, that can be related to questions later on in a medical student's repertoire. So for instance, I've seen plenty of questions that try to relate which part of the intestines, the small intestines, are going to be affected if they have a deficiency in this nutrient, in B12 or in iron or something like that. And it's really easy to mix up which section it is. So by visualizing this process, maybe even starting off with some YouTube videos to get an idea of it, but then making it your own afterwards and adding in these substances and having them disappear as you go throughout the pathway could be a great way to keep everything in order and keep track of where things are being absorbed and keep track of which location is most likely to be diseased if they have a problem with that nutrient.
Yeah, exactly. I completely agree. That's one of the great benefits of this technique, and which is why I like it so much, and which is why I wanted to spend some time on it, because it allows you to take in a lot of information that can be easily mixed up with related information. For example, we can mix up something from the stomach with the small intestine, but if we're visually seeing everything happening, if we visually see what happens in the stomach, and we can see that different things are happening in the small intestine, then we can keep a lot of data separate and more organized in our head.
Agreed. I still get that stuff mixed up all the time. So implement this early and it'll be very beneficial.
Exactly.
So we have one more technique that you were going to bring up, correct? The mind mapping.
Yeah, go ahead.
So yeah, I know we've covered mind mapping briefly here and there. And actually, when we first recorded this episode, it was going to be a unique introduction here. So now I got to see how this is going to fit in with another one that I just did recently. But doing this via audio is very difficult. So I'm always interested to see how everyone explains how to do mind mapping and how to do it in this format so that the audience can understand. So do we have a good example or description of what it is and maybe an example to go off of? Yeah,
so I'll describe mind mapping and I'll try to use some analogies to help people understand it, even though it's through audio. And although it's been kind of talked about in another episode, it'll be good to hear it because since we're doing it over audio, it's kind of hard to really see what a mind map is. But more or less, mind map is a different way to take notes. It differs from the standard method of line-by-line note-taking, where you start at the top of the page. With mind maps, you don't start at the top of the page, but rather in the middle or center of the page. And instead of noting information line by line, you spread out like a spider web. A good analogy for a mind map is an octopus. So the head of the octopus is the center of the map, and then the arms spread out in all directions. And if you can imagine within each arm, other arms extending, kind of like how a tree branch has many smaller branches, then you can kind of get a good visual representation of what a mind map looks like. So the head is the center. The first level arms are the subtopics, and then the second and third level arms are the lower level topics. So if we were going to use an illustration to help describe what a mind map is or how it could be put together, I think the best illustration would be solar system. So if we were going to mind map a solar system, we would put the word solar system in the center of the map, and then each of the planets would be represented by one of the arms. And then we would detail each of the planets with the subarms, and then we can go further and further with additional branches. For example, Venus is the second planet from the sun. So we would put Venus on the main arm, and then we would list its features. It's gaseous, rocky, and also it's a very hot planet. So we would extend 3 branches from Venus, label one gaseous, the other rocky, and the third hot. And if we wanted to go deeper, we can detail the features of the features. So if we wanted to describe what kind of gases are in Venus, we would create a branch from gaseous and label one carbon dioxide and label the other nitrogen, because those are the gases that are on that planet. And then we would do that with other planets. We would say, let's say Mars, we would put Mars on the main level branch and then extend out with sub branches to list its features, such as that it's red, it has a thin atmosphere, and also it has 2 moons. So we'd create one branch for red, one branch for thin atmosphere, and one branch for 2 moons. And then if we wanted to go further, we could. For example, if we wanted to detail why it's red, we can create a sub branch saying rusted iron and another sub branch dust storm, because those are the 2 reasons why Mars looks red. So hopefully this gives your listeners a visual of a mind map without actually seeing a visual.
And one thing I really love about mind maps for note taking, and depending on how you set them up, everyone's a little different. Traditionally, you use different colors for different branches on this tree, on this diagram. So it kind of visually separates all the material for you. But also you can make multiple levels. So you could start off with one that's a very general level. So medicine, and then the branches are all of the disciplines you learn in medicine. Then you can, on a separate page, make one that, the center of it is anatomy, since we keep using anatomy as an example in this episode. And you can have anatomy of the head and neck, anatomy of the arms, anatomy of the legs as separate branches. You can infinitely zoom in and zoom out, basically, of your notes, and having them visual, color coordinated. Most people recommend to do little diagrams for them. Can really make it easier to picture these later on a test or something than just your outline of notes that, as far as mine go anyway, are always a mess.
Yeah. Well, I think you sound like the mind mapping expert here, and I agree with everything you said. What's really great about mind mapping is that they don't have to be just in black and white, pen and paper. It can be colored, so we can color different branches, and the branches can be colored in different ways. So we can color all the hierarchies. We can make it so each hierarchy is a different color, so we can see the hierarchy differently. Like we can make the first level branches one color, and then the second level branch is another color, and then the third level branch another color. So the hierarchy is very apparent. Or we could do it by branch. So we'll just have one branch that leads to one discipline, be one color. So we know that everything that it's going to be green, it's going to be talking about one discipline. And then we can make another set of branches, another color. So when we see something in blue, we know it's talking about this specific discipline or this specific anatomy. So that's really interesting. But then we can also incorporate images. Let's say we were going to mind map the GI tract. So as I had mentioned, the digestive tract is made up of a lot of parts: esophagus, stomach, as well as liver and small intestine. And so we would create a branch stemming out from the center, one to esophagus, another branch stemming out from the center, one to stomach, and then list the details of the esophagus and then list the details of the stomach, and keep everything like neatly organized and separate. And once we did that for all of the organs, we would have a very organized and detailed map with information that is similar staying together and that is dissimilar staying apart. For example, if we think of bile, we know that it relates to liver because there's a branch stemming from it. We know not to confuse it with stomach or small intestine because there are no branches. And it's the same thing with hydrochloric acid. If we see we know not to confuse it with liver because it doesn't connect to liver, it connects to stomach. So it's really nice to kind of get that visual representation.
Yeah, it definitely helps to categorize them a little bit differently than your normal notes would. And just location-based visual memories help a lot with this type of stuff. Like people will remember if a word or a topic was on the right side of the page or left side of the page. So sketching these out in a particular manner, especially after some practice, can definitely help you categorize them and not mix up similar information as much. I actually wanted to write a mind mapping for medical students kind of book, but somebody already stole the name and everything in there is not even really a mind map. So
I think I may know what book you're talking about. It's on Amazon. It's like mind mapping for...
Yeah, I think there's mind mapping for medicine and another for medical students or something like that. And none of them are actually mind maps as far as any definition that I've heard. So kind of annoying that they took the title I wanted, but
but you know what? I think you could still make a similar title. But more importantly, it seems like you got some really great ideas for how medical students can understand and retain information, like with this visualization guided visualizations as well as a mind mapping. So I think you just got to get on it before somebody steals your ideas.
Yeah, I need more time. I need some assistance. Actually, speaking of, I'll toss in this little promo here. I believe by the time this airs, the book will already be out. So a book I've been working on all year is called Read This Before Medical School. And you don't need to read it before medical school. You can read it in medical school, but it takes a lot of the information from past interviews and my educational psych degree and my medical degree and kind of wraps it into like the ultimate, but very condensed. It's only like 160 pages study guide kind of thing. So little shameless plug there for myself.
Hey, it's your podcast, so no shame in that. But I do want to rip on one of the things you said about mind mapping being like a form of location-based memory. And it totally is. You can think of mind map as a memory palace, but instead of using a physical location, the mind map is the location and all the different branches and sub-branches serve as a loci.
That's very true. The location-based information is very, very useful, and mixing up the different techniques, like you just said, with the memory palace and such. Just combining these techniques in whatever way is useful for you independently is like what every student needs to do. But in order to do that, you have to play around with them. You got to just practice and try new things, and get general ideas from people, but don't do what I did, spending most of my time researching them and less time practicing them. Do the reverse.
Yeah, it's all about practice. It's all about actually taking action. And this kind of brings up a really important point that I like to have people and students really understand, that it's not about being passive when it comes to learning or experiences in life. It's really about being active and engaging with information. You see, we Westerners are kind of getting spoiled because we have become accustomed to taking in information experiences passively, sitting in front of a couch watching TV, sitting behind a desk listening to a lecture, or even just sitting on a roller coaster to experience any sort of thrill. And if we want to experience something real, all we do is put on our virtual reality glasses, and without doing anything, we experience the world outside of ourselves. But I want people to understand that it's really important to become active. Like passively reading, listening, and watching is good in the initial stages of learning something. But we want to take that from just taking information, sitting, into actually being engaged and active with the material. And there's many ways to be active. Something simple is just to take notes, but like doing these techniques we're talking about, visualizations, retrieval, mind mapping, allows you to be much more active with the material. And it's about being active and the actual taking action that's going to help record that memory into our brains and our bodies. Because as I had mentioned, memories are stored not just in the head, but all over our bodies. So the act of talking out information, writing information, all of that gets encoded into our body as muscle memory. So again, action is really key.
Agreed. I did a lot of passive learning, and unfortunately, you get knowledge really quickly, so you feel like you're making a lot of progress, but you plateau very quickly too, and it's much more difficult to do the active steps, but you just got to do it. So that came back to bite me in the butt later on.
Yeah, that's how I was. I was just like you, Chase. I thought osmosis was the trick to memory, but it never worked. And like you said, when you're just passively listening, watching, and reading, it seems like you're taking in the information and that it'll be retained for long term, but it's not. In fact, if we just take in information passively, it leaves very quickly. It's the quickest type of memory that leaves. So again, just to reiterate, take action, be active, engage with the material, no matter how simple it seems and whatnot.
I think those are some great parting thoughts. We've got repetition, visualization, mind mapping, and being active, and some really useful materials there. Where can the audience find you and your course for more information?
All right, great. So my name is Cam Knight. People can find me at my website, mindlily.com. That's mindlily.com. And I have a course coming out called Double Your Productivity in Half the Time. And this course is really one of my proudest works. It's a distillation of everything I've learned over the last 10 or 15 years about learning and doing more and getting more done. And unlike a lot of traditional courses that focus a lot on techniques and systems, I really take a very different direction and come from the perspective that as humans, our mind is built to keep us from moving forward. It's hard to believe, but our mind is designed to keep us from taking action and growing. And there's also some reasons for why that is. And it's really important to understand why the mind is holding us back and how it holds us back and what we need to do to get past these blocks and barriers. And only then can we make worthwhile progress. So the course will be coming out by the time this podcast is released. And the name of it is Double Your Productivity in Half the Time. And they can learn more about that at mindlily.com/productivity.
Perfect. We'll have that in the show notes. And also for your free ebook, Triple Your Reading, Memory, and Concentration in 30 Minutes. Those notes are also in the show notes. And depending on when this releases and when your course releases, if there's time, we'll toss in a link to your course in the show notes as well. So yes, audience, use the show notes. I know I say it every episode. Use them. There's a lot of useful information and links there.
Yeah, it's a form of repetition.
Exactly. Well, Cam Knight, thank you so much for coming on the show and for redoing this with me. I know it was a pain in the butt. Our first go around didn't work out, but I'm glad you were able to reschedule.
Hey, great. I really enjoyed it. Thanks for having me on again. And this was as fun as the last time. And hopefully this time your audience can get a lot of good information that they can use for not just understanding information better, but retaining it for longer.
Agreed.
All right.
Thank you so much. Have a good day.
All right. Thanks.
We hope you enjoyed this episode. For links to connect to us, email us, or for previous episodes, please see the show notes. We'd also love to hear from you, so please send an email or join us on the Medical Nemesis Mastermind Facebook group. Any ideas, tips, tricks, people that you'd like to hear interviewed, we'd love to hear it. Any advice to make the show better and more enjoyable would be greatly appreciated.